Okay, today we're doing the trigonometric functions and right angles, which will include 3 more that we weren't aware of until today. Maybe you were, maybe you weren't. But we're all familiar with sine theta, cosine theta, tangent theta, where this symbol is theta. That's how you read it. So if you were coming from the angle where theta is by angle A, the sine of theta, this would be your opposite leg to that angle, this would be your adjacent leg, and this would be your hypotenuse. So you're familiar with Oscar has a heap of apples, or soa, ka, toa, whichever one you like to use. I don't care. But now we need to memorize the next 3, which are reciprocals. Notice that this one, CSC, stands for the cosecant. SEC stands for secant. And COT is not cot, it's cotangent. You do want to know the names, and I will use them. So if the sine of theta is opposite over hypotenuse, the cosecant of theta, notice it's the reciprocal. It might have been nice if they'd have named that one the secant, but they didn't. So it might have been nice if the S's went together and the C's went together, but they don't. So you have to memorize that the reciprocal of the sine is the cosecant. The reciprocal of the cosine is the secant. And the reciprocal of the tangent is the cotangent. That's the easy pair because they match. But you're going to have to get these straight. They don't have to necessarily have been written down in the exact proper order every time. You need to know which one's which. So all these are our reciprocal functions. Reciprocal functions. All right, so if you just take your if you know the cosine, you can get the secant just by flipping it over. If you know the tangent, you get the cotangent by doing the reciprocal. All right, so here's our first example. We want to do the sine of theta. Well, I can do the sine of theta because the 5 would be the opposite leg to theta, and this would be your hypotenuse. So I can get that one done, but something's missing for the other ones. So I can do 5/13 for the sine, and it's the reciprocal of the cosecant, or they're reciprocals of one another, so I can get the cosecant is 13 over 5. But I can't find any of the others because I am missing the adjacent leg. How could I find it? Pythagorean theorem, yes. Which says leg squared plus leg squared equals hypotenuse squared. So 5 squared plus the adjacent leg squared. Now why don't we, well, I just wrote adjacent leg, equals the hypotenuse 13 squared. So we would subtract, and the adjacent leg squared is equal to 160 minus 25, which would be 144. We take the square root, and the adjacent side would be 12. Okay, so now I can do my cosine. So the cosine of theta would be adjacent over hypotenuse, 12/13. The reciprocal function to the cosine is the secant, which would be then 13 over 12. And then the tangent is opposite over adjacent, so it's 5/12. And the cotangent, which is its reciprocal function, is 12/5. That's how you do it. So now we're going to try another one. First, let's go ahead and find the hypotenuse since it's missing. From theta, the 16 is the opposite leg, and the 12 is the adjacent leg. Okay, so I'm going to do Pythagorean theorem. H squared equals 12 squared plus 16 squared. H squared is 144. What's that? Plus 2? The 216 or 256. I always mess that one up. Just type 1 toward 256. Okay, and then when you add, you get 400. Then you take the square root, and the hypotenuse is 20. All right, now I can start doing my trig ratios. So the sine opposite over hypotenuse is 16 over 20, but that must be reduced. The ratio of those sides would be 4 to 5. Okay, and then the reciprocal of that one is the cosecant. So I'm going to jump down here and write 5 over 4. So I don't have to write 20 over 16. I'll just flip over the reduced fraction. Cosine, adjacent over hypotenuse would be 12/20. Reduced is 5 by 4 top and bottom, 3/5. And so the reciprocal function of that is the secant, so that'd be 5/3. And then finally, the tangent opposite over adjacent would be, opposite theta would be 16, adjacent 12, divide by 4 top and bottom, we get 4/3. And so the cotangent would be 3/4. I just show these connected, and I'm not going to do that anymore. I just color coded them. Anybody still need this page? All right. Number 3. Now I'm just going to write sine, cosine, and tangent, and then I'm going to do the cosecant, secant, and cotangent. First, I'm going to find my adjacent leg. So I'm missing a side. Okay, so 17 squared, and it doesn't matter if you start with the hypotenuse, then you say 17 squared equals 8 squared plus, and if you want to call it x or whatever you want to call it. All right, that's 289, 64. Subtract 64, we get 225. Wow, these are coming out nice. Take the square root, we should be getting the missing side is 15. Okay, if you'd like to label the things from the theta, this would be opposite would be your 8, adjacent would be your 15, and the hypotenuse is 17. Okay, so sine would be opposite adjacent over hypotenuse, 8/17. No reducing needed. Cosine theta would be adjacent over hypotenuse, 15/17. Tangent, opposite over adjacent, 8/15. And then the cosecant is the reciprocal. And don't be assuming every time you do these that these are going to be written down for you in this correct order. Okay, make sure you know which one goes with which. Sine and cosecant are reciprocals, so that's 17/8. Cosine and secant are reciprocals, 17/5. And cotangent and tangent, 15/8 for cotangent. Oopsie, I forgot the, did I say 5? I think I just forgot to write the 1. Thank you. 17/15, of course. All right, next page we got, or not next page, this is still on the same page. In a right triangle, angle A and B are acute. So we'll call angle C the right angle. So I'm going to draw a generic triangle. And label it ABC. With C the right angle. And it said it was a right triangle, so we had to have a right angle in it. Didn't mean to cross that word out, but okay. So if the tangent of A is 7/12, you go over to A, that's where you look from. Looks like you could try there. And you say tangent is opposite over adjacent. So the opposite side would be side CB is 7, and the side that would be 12 would be AC. It wants us to give the cosine of angle A. Well, we need the hypotenuse then, because the ratio of the cosine is adjacent leg to hypotenuse. We got to find the h value. The hypotenuse squared would equal the leg squared and added. So let's see, what's 7 squared plus 12 squared? 144 plus 49, 193. Okay, and then we need to take the square root of 193. Now, you might be wondering, does 193 have any common factors that are perfect squares? Well, you could test it out. It's prime. I happen to know it's prime. Because I know some divisibility tests that you maybe aren't aware of. I can figure it out. But I can tell it's not divisible by 3 because the sum of the digits is not divisible by 3. That's a divisibility test for divisibility by 3 or 6. Anyway, moving on. Square root of 193 is the hypotenuse. So now I can say the cosine of A is adjacent leg to angle A is 12 over hypotenuse, the square root of 193. You can't leave radicals in your basement because they might blow up your house, so you multiply by the radical you don't want down there. So he'll come upstairs where you can watch him. I know it's silly. 12 times the square root of 193 over 193. And you could check on your calc if 12 over 193 reduces. It doesn't. So that would be the answer to that question. And you will not be writing anything in decimal form. Okay, so do not do it. You need radicals. Simplified radicals at that. All right. Next problem, another generic triangle with a right angle at C and an angle A and an angle B. It says the cosine of A is 1/2. So you go up to A, and notice I did not write opposite or hypotenuse or anything on these because I don't know what they're going to ask me. So I can't name them unless I know which angle I'm coming from. This one does say tan A, so I do know I'm going to come from angle A, so you could label them. But don't assume that because you might be asked other questions. Like I might say, what's the sine of B? Okay, so I don't want to label things unless you want to just label the hypotenuse. That's up to you. If you're coming from A, though, and the cosine is up as adjacent leg to hypotenuse, I do know the hypotenuse would be 2, and the adjacent leg to angle A would be 1. So that would go on AC. I need to find the missing side down here. So there's a couple of ways we could figure that out. I'll just call it x for the moment. X squared plus 1 squared equals 2 squared. And that gives me x squared plus 1 is 4. Subtracting 1 from both sides gives me 3, and taking the square root gives me the missing side is the square root of 3. I hope you remember something back from geometry. Now this isn't drawn to scale. You remember something that's on my board? There's a hint in the room. If this side's n, this is 30 and this is 60, then the long side is twice the short leg, which would be your hypotenuse is twice the short leg, and the short leg times the square root of 3 is the long leg. That was back from geometry class. That's going to be really important very soon in this class. That special right triangle pattern. You're going to need to know that for the rest of your math career. Okay. All right, so anyway, let's do what we need to do here. What's the tangent of A? Go up to A, it'd be opposite over adjacent, so it's just the square root of 3, or square root of 3 over 1. You realize now we're going to be able to do the tan of 30, all the trig functions of 30 degrees and 60 degrees, and that has all got to do with that thing I mentioned about the unit circle. It's going to come up in the near future. One more, I believe, before we're moved on to a couple of word problems. Next one, make my generic triangle with a right angle C, a acute angle A, and acute angle B. Sine of A is 7/12. Sine is opposite to the angle, 7, opposite side on CB, and hypotenuse, so that would be 12. I need to find out the missing leg so I can do the tangent of angle B. So let's just call it x. X squared plus 7 squared equals 12 squared. 12 squared minus 7 squared, 144 minus 49 is 90. How do you want to do it? 95, right? Okay. Take the square root. Square root of 95 is our missing leg. All right. So now I can say the tangent of B, coming from angle B now, not A. Tangent is opposite over adjacent, so it's the square root of 95 over 7. That doesn't simplify. All right, on to a couple word problems on the back. These are just pretty much right triangle trig word problems. Then you got to get used to drawing these. John stands 150 meters from a water tower. All right, I'm going to make a new water tower, even though that's a nice one in that picture. Looks kind of like an alien to me, but anyway. All right, so John stands over here. Apparently, it didn't say anything about, it says how tall is the tower, so I want to find the height of the tower. John stands 150 meters away from there, and he sights the top of the angle at an angle of elevation of 36 degrees. Well, if he's standing there, I'm just going to make that straighter. They didn't tell me about his height, so I'm just going to assume that John's prone. He is laying on the ground. All right. All right, but then he's flipped over and he's looking up. He's looking up at the tower. Okay. Angle of elevation is an angle opening up from the horizontal, so it would be here by John's face. For John. We want to know the height of the tower, so we go opposite over adjacent, which would tell us to use the tangent. So the setup I want to see in your papers, tangent of 36 equals x over 150. We calculate 150 tan 36. It was 36, right? Yeah, we got 108.98. Which is going to round to 109. 109 what? Meters tall. Okay. Pay attention to your labels. Okay, now we got Jessica standing 150 feet from the base of a tall building. Okay, so I got a building. It's weird shape. She measures the angle from her eye to the top of the building to be 84 degrees. Well, Jessica's actually standing up because it says if her eye level is 5 feet above the ground. Okay, so let's have Jessica standing here. I'll put a little skirt on her. Okay. Jessica is looking, and you have to think of her eyeballs. If she was looking straight ahead, you have to think of that as your horizon line. And then she's looking at the top of the building at an angle. Boy, I didn't make that angle 84, but there we go, 84 degrees. So she must have been closer. What's the distance she is from the base of the building? Okay, that would go down here. But you can also put it on your triangle right there. And then it says, how tall is the building? Well, what are we going to actually get from this diagram? We're going to get this, right? So this is 5. Okay, so we got a right angle there because we want our buildings to stand up straight so they don't topple over. And we're going to be able to find the height, that much of the height. So we're going to need to add on 5 once we're done. This is another tangent ratio because opposite the 84 degree angle is x and adjacent is 150. So we calculate 150 tan 84, tangent of 84. And then we go and add on 1427.2 plus 5. So our final answer, 1432.2 feet tall. Okay, short lesson. Your assignment, which I have worked into a worksheet, is page 813. Enjoy. Get something done.